Tomorrow will be better. We have a diagram on the board and the question says, given that the frequency is 2 hertz, find the wave speed. Like I always say, dear friends, let's begin by writing down the equation which is relevant to the question we've been asked. The most relevant one here, dear friends, is wave speed is equal to lambda f. In this formula, lambda represents the wavelength and then f the frequency. Now you're wondering, the next thing to do is let's look at the formula and identify what we have and also what we don't have. Clearly, we have the frequency which is stated here, but we seemingly don't have the wavelength. So how do we get the wavelength? Follow me, dear friends. Solution. Now the diagram says it all. In the diagram, we have a certain distance which is equal to 1 meter. Now, by definition, dear friends, the wavelength of any wave is the distance between two successive particles which are in phase. Now, an immediate consequence of this definition is the fact that wavelength will be equal to the distance between two successive crests or two successive troughs. But in the diagram, we are given the distance between a crest and the next trough. Okay, so what we can get from here is, if the distance between two successive crests is equal to one full wavelength, then the distance between a crest and the next trough should be half or midway of a complete wavelength. So what we are saying is, therefore, our wavelength is going to be 1 meter times 2, which is equal to 2 meters. Now, I haven't had every element of my formula. Let me go ahead to apply and obtain wave speed, which will be equal to wavelength, which is now 2, now times the frequency, which is 2 hertz. And if you punch well, we should obtain 4 meters per second, because this is the SI unit for speed. Tomorrow will be better.